Well, that's fun. Apparently I've got a small bug in my countdown timer app that I wrote. Welcome back, everyone. Going to continue on more with the ColorKraken example, but this time switching the flavor. So last time there was a bunch of discussion on unit testing. We kind of ran into a problem at the very end, and it ended up being related to tasks and how to actually deal with some async void stuff. So I thought that would dovetail nicely into a discussion on tasks, TPL, threading, and all that fun stuff. So I'm going to warn people up front a little bit. If you are just getting started with C# and WPF, this might not be the talk for you. I'll just put it out there. Threading is probably one of the most complicated areas to get your head around. And so if you are just learning, don't stress about it. Come back to it after you've gotten some of the other basics. Check out some of the previous videos on kind of getting started with C# and WPF. The building ColorKraken video is a great one to take a look at. It'll probably be a little bit more gentle of an introduction than what I'm going to do tonight. So again, this tends to be a little bit more complicated stuff, despite the fact that a lot of people bill it as easy. So before we get too deep into the weeds, I want to call out just a couple things. So first of all, hey Andrew, welcome back. Hey, I saw your tweet putting out the dependency injection video. Thank you for that. I appreciate it. Okay, so let me go a little bigger. So for people who may just be catching up, the repo I'm playing in is that one there. And specifically inside of here, there is a branch called unit test, which is the branch that we started last week and where I'm going to continue on from. Since last week, there was a couple changes I made to the code, and I tried to keep it simple. So the problem, just to recall for people who weren't there, we started writing unit tests over our view model class, which is a good thing to do. But our view model class was very tightly coupled to implementation. This app, for people who are not familiar with it, it is a way to theme your Git Kraken color. So as you can see, normally a lot of these things here, like this little plus, would be showing up as green. I've taken this theming app and just tweaked some of the colors for fun. No other real good way of saying it. It was for fun. In fact, here, quick demo. We'll just prove that the app still works. Come in here real quick. As soon as my app starts. Hello? That was fun. Hey, Justin Bieber. Great to see you back again. So we're just going to pick on this color here, and I'm going to pull Git Kraken up so I can do this with each of them. So this is the main app background. I think we're going to go purple with it, and we're going to lighten it up. Something like that, maybe. Oh, that is way too light. Darken that. More down. Dark purple. Go with a nice deep. Bring that over there a little more. There. Just so we can see that we're themed. We're going with a nice light purple for reasons. Okay, so that is the app. It lets you go through, muck with your themes, create new themes, delete themes, change the colors, hit apply, you see it work, everyone's happy. And then as you can see, there's a whole slew of brushes that you can change and all of that jazz. So that's the app, that's what we're playing with. So we started writing unit tests over this. And when we got to testing some of the interaction, we ran into this case where the app itself was wanting to do work. There was some task.run stuff in there. There was a lot of file I/O happening, and it wasn't trivial to be able to test the view model, because in order to test it, we had to have all of that stuff pretty much set up and in a working state. And there was, in the case that we were looking to test before, because it was async void, we had no way of knowing when the test was done, so we didn't know when to actually do our assertion portion of the test, checking to make sure that the conditions were met. So what I did is I went through, and this latest commit here, I'll just show it off. I went through, and I mentioned doing this at the end of the last stream. I created up a new iTheme manager class and added a bunch of methods to it. And I went I did my best to go through and make sure that I didn't change the contents of the methods or change them as little as possible in order to get them working. So the contents of these methods are largely just copied straight out of the main window view model. But they're things like the create. It does all of the file creation stuff, the JSON writing stuff, the reading of the files back out, retrieving the categories, saving a theme back out, deleting a theme. All of that stuff got moved into this manager class and put behind an interface. So recalling back to last week's discussion, this is referred to as putting a seam in your code, giving yourself an ability to test. So then it meant that our main window view model got a lot smaller. So rather than the process service, that got moved inside of this as well. We now just have a theme manager, which is an instance of an iTheme manager. That was added into the constructor as a dependency. And you'll note by adding this one dependency in, these other two dependencies disappeared because their usage went into those other methods. So this guy here, his constructor, actually took in those same two dependencies to be able to do his work. So it helped us separate out some of those concerns a little bit, which was great. And then a lot of this code here just converted from actually doing the work to shelling out to something else. So get theme manager, all of the new theme stuff. The one thing that got a little interesting was some of the things where these try catches were around very specific methods. I opted for just leaving the try catch around the entire method. And inside of the theme manager itself, what I ended up doing is just allowing it to throw right back out. So it'll throw in a few extra cases than it was, or I should say, if it throws in a few extra cases, those will now bubble up to the show error method where they weren't before. I felt like that was okay. I tried to drop the word file out of it as well, since I wanted my main window view model to be ignorant of the fact that they were files. It just, for all it needs to know, it's dealing with themes, it's not dealing with files. That's somebody else's problem. Let's see. So all of this save stuff got moved into just the save theme method. Whole bunch of code deleted. And then one other comment that I caught here is in the delete method. It's got some logic around which themes it's allowed to delete. So default themes we aren't allowed to delete. And that sort of felt like something that should move into the manager, because that was more around the logic that it's doing. There's a general coding principle, and actually, let me pull up that site. Where is it? So, DevIQ, tell, don't ask. Yeah, this one. All right. No, this is what I want. This one here. So for people who are interested, this site here has a lot of really good descriptions of, I won't necessarily say buzzwords, but good programming principles to know. So if you aren't familiar with these words, like specifically here's the tell don't ask one, this is a great one to go and check out. I've worked with one of the maintainers of this site. It's very quality stuff. So the question, I wonder how ColorKraken instantly picks up colors from a rewritten file, file system watcher or something similar to that. Yeah. So ColorKraken is a Electron-based application. So, and I'm less familiar with the Electron APIs, but the file system the low-level file system that File System Watcher is built on top of, those are exposed out, and I would be shocked if Electron wasn't surfacing, something similar to that. I mean, the bone dead way of doing it is you just put a timer and check like the last updated timestamp on a file. Don't do this. This is bad. But given the problem with doing that is you'll often see your CPU usage jump because it has to evaluate that timer tick. So it's CPU hungry to get that kind of behavior, and I don't see that with ColorKraken. So, but on DevIQ, if people are interested in a lot of these coding principles, or even just these practices, if you're not familiar with a lot of these are at least a good set of things to know. I wouldn't expect everybody to know everything in here, but I'd expect you to know how to find them. So just like, especially when my company is interviewing people, trying to kind of pick at not necessarily how well people know the terms, but if people can understand the concepts that are put in here, things like pair programming. Why is that good? What are the benefits to it? Or shipping as a feature, or test-driven development. Those types of things, being able to at least explain those concepts is excellent. Okay, so worth noting. So this here, and that was, so all of that to say, that was the reason for me putting this to do here, is this is default. Feels like a violation of tell, don't ask. So we should just tell the theme manager to delete. We shouldn't be asking and querying about the state ahead of time, because that means if we ever end up invoking delete theme from somewhere else, that code would have to have that same logic. That's a good pit to fall into with bugs. Okay. So, and as it currently stands now, everything is broken, which is awesome. Not bad. Good stuff. So currently the way the test sits, everything is completely and utterly broken. And it's broken in predictable ways that we would expect. So let's just take a couple minutes and see if we can get these guys back green, because I'd prefer to start from a green state, but I figured I would do that here, and then we could circle through and do this. And I'm thinking that this is the one that has a timeout that's waiting for a timeout. But we can probably, you'll note previously the test run took 5 seconds. For 4 tests, that's pretty pitiful. That is slow. So let's jump in and see about cleaning these up. So once again, for anybody on enterprise grade Visual Studio, I do have live unit testing turned on, which is how you see the little X's and whatnot on there. We'll just start at the top and kind of burn through these real quick. So we can see this on refresh. This guy was waiting for, so we were invoking on refresh. It's called Lowe's themes, and it is expected to go through and do all of the property bits. Now I'm fairly confident, based upon how this is working and the change that I just made, the most likely explanation for why this is broken is it's making a call to get themes, and get themes is returning nothing, whereas before it was returning something. So what we will do is we will go with a mock theme manager mocker get mock. So I briefly introduced the concept of auto mocker last time, of how this works. But one good thing to know, and I actually had a colleague bring it up to me earlier today, is oftentimes he'll see people call get mock to get the mock out, and then do something weird like mocker use to put the mock back in, and that's just not necessary. Something like this, which is way overkill. Auto mocker, once you get something out, it holds on to it. So the only thing auto mocker does not hold on to is the return from create instance. Everything else auto mocker holds on to and basically treats as a single. So we're gonna just do theme manager, because this thing was specifically waiting for selected theme change. So what I suspect is happening is this guy is coming in here, probably throwing an exception and landing here. And actually we can confirm that really quick before we actually fix the bug. Let's do that, because you can see this property values here is broken. Why is, oh, it's just a UI issue. Okay, so we'll just right click in here and hit debug test. And I'm fairly confident, given what line of the test failed, that we probably are hitting an exception. Yeah, so there it is. So as soon as we start debugging, we hit an unhandled exception, null reference exception, which is the universal definition for programmer done screwed up. So, and in this case, theme manager, this one might not be intuitive to a lot of people of where the null reference is, because anywhere you hover in this line of code, you're not going to find the null at all. See, I knew this code would be great for task parallel stuff. So the fun part of where this null is actually coming from is based upon what is being evaluated here. So you'll note this is using an await for each. So if we look at the signature of get categories, boom. Get categories is an async enumerable. So this is different than an enumerable. And the key change here is normally with an enumerable, the entire enumerable would have to be built up and handed back, and individual items could be handed back, but the call on enumerable to get the next item or to move next is what the method is called, isn't asynchronous. It's a synchronous call. So this allows asynchronous code to basically churn items back one at a time and go ping, 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 ping. Which is great. That's what we want. But in the case of a mock, what is happening is by default, if you don't do anything with AutoMocker, or I guess in this case, this is just a regular mock. Here, it's not even AutoMocker, so MOQ, mock. The default behavior of all of your methods is just to return the default value. And in this case, the default value of a interface or a reference type, which is what this async enumerable will be, is null. So it's returning back a null, and then C# very helpfully takes this nice little await for each and goes, oh, hang on, I know what to do with this async enumerable. It unpacks it and sets it up to iterate and do those asynchronous calls for you, which is perfect. We wrote 5 little letters, and C# built up a whole bunch of the method and set up the for each for us, which is perfect. That's what we want. But what is unclear from this is that the return from get categories is null, and that's what's causing our null reference exception. A similar thing can be seen on enumerable methods that you for each over. Another similar thing can be seen for like task methods. So for example, what's our theme manager? So for example, create theme, right? So if we do theme manager create theme, this guy is wrong button. Sorry, one second. Let's see. Boom. If you were to await an async method like this for create theme, we'll just pretend like we've got all of our stuff that we need. Null. This will also end up throwing a no reference exception. So in general, enumerable methods, async enumerable, and task returning methods are not expected to return null. It is bad practice, simply because of the language support for these. So for the task deleted ones, you should always be returning like task completed task or task from result, not a null. Almost never should you be returning a null. Throw an exception, return a completed task or similar. Don't return null from a task method, because you end up having your callers get a no reference exception at points that are fairly confusing and not included. Multi-threaded in the order the record is then lost. So Justin Bieber question: async enumerable written synchronously one at a time, but you can read values multi-threaded, or is it possible to write multi-threaded? The order of the record then is lost. So that is a good question. So in the case of async enumerable, and that is perfect because we're going to end up having to dive into this guy a little bit. So let's just jump to his implementation. So in this case, they are still, because we are using the async and await keyword in C#, this allows us to write synchronous looking code that is asynchronous. So in this case, the order isn't lost because it is, I won't say writing, it is appending items into the enumerable one at a time. So every time you hit this yield return, just like you would in a regular enumerable method, that's putting another item into that async enumerable that will then be read out later. So it's not necessarily written synchronously one at a time, because of all of these await keywords, it is very likely and plausible that what is actually ended up happening is different threads are actually appending items in. So it's technically asynchronous. The key difference though is when these are being consumed up here, this await allows C# to grab the next item, do the work inside the for each, which in this case is just add to a list, nothing fancy. And I will point out there are extension methods for doing async enumerable to list as well. I'm just not using them. I felt like this was cleaner. You await the async enumerable. You hit that yield return, one item comes back. That item gets added. It gets back up to the beginning of the for each again. That method is an async method that is awaited while that next item is retrieved. It's brought back inside the for each again, and we go. So it's not a full-blown message pump or channel where one thing's just constantly pushing things into a queue and another thing's potentially reading things off. There are, let's see, C#. This guy, system threading channels. There is a, to get the behavior similar to what you were wanting, this is what you're looking for is, this is probably a good one. Oh, this is Steven. Yes. This will be an excellent. Yes, this is what I'm looking for. To get sort of that behavior that you were describing where you can kind of have one thing pushing into another, almost like when you connect up two streams to each other. Channels kind of gives you that plug and play type behavior that you're describing, where you could have something potentially pushing multiple things in, something reading out the other side. Now the difference being that with a channel, it really is kind of plugging things together, almost in a pipeline, as it were. Having things be put in, enqueued, dequeued, and Steven does a great job of going through the reading and writing of these things. There is another really common class, let's see, C# blocking collection, that is worth knowing about. This one I have made great use of many a time. Oh, good. There's a good sample in here, too. Excellent. A blocking collection is another situation where you can kind of get the behavior that you are describing. So you'll note in this situation, and it's kind of weird the way they nested this, oftentimes you have the thing adding to the collection in one place and the thing reading somewhere else. But with a blocking collection, you can have something going add. And then the really nice part, do they show it in here? There it is, for each. You can, on your blocking collection, there's a method called get consuming enumerable. So this for each will block, as the name implies, and wait for the next item. So he will just rip through items in the collection until he either reaches the end of the collection, or if there is nothing there, it'll just pause and wait for the next one to come in, which can be really handy. So this one is a rather nice thing, but the more generalized pattern is the channels. Is there a synchronous dictionary under the hood of async enumerable? As a result, records turn out nevertheless synchronous. Not a synchronous dictionary. So there is, so with async enumerable, and I guess with enumerables in general, the magical interview keyword that most people are looking for is deferred execution. So actually, let's have a quick discussion on innumerable then, because I want to just jump to a test class. We'll come back to fixing these in a minute. just jump in here. Fact public void deferred execution. So if you're ever in an interview and somebody starts asking you about innumerable, this is the magical word that they are almost assuredly looking for, or at least a description of the behavior. So let's imagine we have an enumerable events, right? And this, we'll get back to async enumerable, but I think it's easier to grasp if we start with innumerable first. We'll call it numbers. Enumerable, and then this really doesn't matter. The thing on the right hand side of the equals, we get an enumerable from somewhere. So the important thing to note is what an enumerable looks like. So the innumerable interface is fairly simple. All it has is an enumerator. Okay. An enumerator ends up with 3 properties on it, or I guess a few. So there is, maybe it's 4. There is a current property, which is just give me the current item. And then buried down underneath it, you can ignore this current because the other one is going to be the typed one. There is move next and reset. And practically speaking, reset, you shouldn't really rely on. It's often not possible to reset an enumerable. There's a lot of kind of built-in enumerables. They are pretty much a one-way street. They are always just give me the next item, give me the next item, give me the next item. So normally what people end up doing is they start writing for each, int number in numbers. And this goes through and, do stuff. But what's important to note is what this actually under the hood ends up compiling into is something that is, and I'm doing this from memory, so don't quote me on this, but it is something like this. Let's see. Actually, we'll get rid of the try catch. We'll just use the using statement. So using numbers enumerator gets, let's see, numbers. Oh. Syntax. Oh. Spelling counts. Or as I usually tell people in computer science, doesn't matter that you spell accurately, it just matters that you spell consistently. Okay, so we get the enumerator out, and then it does something akin to while numbers enumerator move next, int current, numbers enumerator current, and then do stuff with current. So not a perfect example. There's a little more intricate stuff, but functionally this is ultimately when you do for each over an innumerable, what ends up happening. Now, the other thing to be aware of, so let's go back to that deferred execution comment. So innumerable int, and let's call it, I don't know, get numbers. Right? So we could imagine for int I equal to 0, I less than 10, I plus plus, yield return I. Okay? And this will be pretty much the exact same as this. Now, let's imagine that we have, say, int count, right? And then let's also say that we want to say, okay, if count is less than 0, throw new argument exception and to-do, right? Actually fill out the exception correctly. This method is now implemented incorrectly. And it's a little unfortunate that it is so, but it's important to understand how innumerable works. This is the deferred execution. So for example, I pass -1. So normally what would happen is as soon as we call get numbers, we would expect this exception to be thrown, right? So I'm going to put a breakpoint here, and I will debug this test. you'll note I got past my call to get numbers, and I have not thrown an argument exception yet. A similar thing could be seen if I put we'll just back up the execution pointer here. So if I go right here, I've got a breakpoint on the opening curly brace on 41 inside of get numbers. If I step over, I never get inside of this method. Excuse me. This is the deferred execution point of it. So when discussing enumerable, the key part that's worth noting is under the hood, when the compiler sees the yield return, or if you invoke pretty much any enumerable method, any method that returns an enumerable is expected to have deferred execution. That means that the method itself will not actually perform the work of getting the items until you actually start iterating the enumerable. So at this point, once we do the for each, that will start iterating. Down here, the iteration would happen on the move next. So for example, I'm just going to skip that for each and jump down to here. So you'll note there, getting the enumerator doesn't cause a problem, right? But as soon as I call move next, now we jump inside of it. So on each call to move next, and we're just going to, so this count would throw an exception, but I'm just going to bypass that for a moment. Or actually, I'll leave it there because this will just end us getting in a weird state with that less than. What will happen is on an enumerable method with a yield return, the function only runs until it hits a yield return. The enumerable is keeping track of where it was. It hands back that current value here. Move next returns true because it got an item. It hit a yield return. That's effectively what the Boolean return from move next means is, was I given back an item? From there, the item is handed back. It is in the current property. It is then retrieved and able to do stuff with it. And then it moves on to the next one. On the next call to move next, and let's actually do this. On the next call to move next, we'll just do 3 just to keep it small. And I'm going to comment this out so I don't have to jump it. Debug test. Okay, so we should be, yeah, so we hit that, we go into our move next, we jump in, we do our argument check, we come into here, we check count, in this case is 3, I is 0, so we execute, and you'll note as soon as I hit the yield return, I jump back out of my iterator method. I come into here, current in this case is 0 because I was 0, that's great. I come back around and it calls enumerator move next. Now the enumerator goes back to what it was doing and says, okay, let me get the next value for you. So it comes into here and says, well, I left off at the yield return, let's start running from that point. So it executes, does the for loop, hits another yield return, and as the name implies, it yields back up to the other one, returning the value. Because it yielded or it returned a value, move next returns true. We get the next current value, which is 1, and you can imagine we do stuff with number 1. We come around, do the same thing into here, and this time it should be 2. Great. And then we come in and we call move next another time. So note, our count is 3, but we're going to end up calling move next 4 times because it doesn't know that it's not going to hit a yield return until it leaves this iterator method. So now it goes up here, continues doing this logic. I goes up, I is no longer less than count. It exits the method. So now the iterator knows, I've exited. There was no longer a value returned back to me. So now move next returns false. We jump out and we keep going. All of this logic and built up stuff is what this magical for each is giving for you. Like all of that kind of just happens under the hood. You don't have to think about it. It's wonderful. Sort of this extra enumerator stuff, you'll hear people make comments about how like LINQ is slower than regular for loops and that kind of thing. This is what they're referring to. The small overhead of doing the enumerators does add overhead. And so for each is mildly slower than a for loop. Do not go changing all your for loops or your for eaches to for loops. Unless you have a performance benchmark showing you that you need the performance there, the simplicity and readability of a for each usually trumps the somewhat obtuse ways of writing old C#. So keep that in mind. If you've got a performance benchmark and you can show that you need it, go for it, have at it. But premature optimization is the root of all evil. At least the root of programmer evil. Okay, so one comment more and then we will go to async enumerable. So I made the comment here that this method was implemented incorrectly. So the key part here is if you have an enumerable method where you need to do some sort of precondition checking, because right now we would often want to separate these enumerable methods between the stuff that should run immediately. So we would want to do our bounds checking here because we would want this thing to crash immediately when getNumbers was called with a bad count rather than down where it gets iterated over. Because this is where the caller is going to expect a problem if there's going to be a precondition check. And we would hopefully put just this in the deferred execution part. So the easy way to do this. So what causes the deferred execution is the yield return. This magical little thing causes this method to get compiled slightly differently. Yet again, all these fun ways in C# you can make your methods behave differently. Yield return will cause your method to have that deferred execution behavior. So we want to separate this thing from this thing. And so a nice cheater way to do this is with a local function. So int, and oftentimes I will just call it something like get numbers implementation. So this could be a separate method if you wanted, not a big deal. And then this will take in int count. Okay, so that should be happy now. And then this guy here, return get, wow, I did not spell that well, did I? Let's try that again. Boom. Yeah. So this here is a proper implementation of an iterator method. So we separate it out because this method here, getNumbers, no longer contains a yield return. It contains just a return statement. This no longer has deferred execution behavior. Okay, so getNumbers no longer has deferred execution behavior because we're no longer using yield return. Instead, what we did is we created a second function, and I made it a local function. This could just as easily be a separate function if you wanted it to be. But because it's only expected to be consumed from here, a local function, in my opinion, makes sense. And in here, I use the yield return. So this method will have deferred execution behavior. So now what happens if we put a breakpoint here, my live unit testing, helpfully showing that I've changed behavior. Now what happens if I debug this? When I go to step, you'll note rather than jumping down to the next line, I step into getNumbers now. And now it'll evaluate the count and throw the argument exception at the point where it should, rather than deferred. So if we put in a real thing, we'll see some really, and I'm going to put a breakpoint there, and I'm going to put a breakpoint here just to punctuate the point. Okay, so we come in here, it'll do our precondition checking, it'll now call here, and you'll note I hit this return statement, and then I immediately jump down to this closing curly brace. I don't go inside getNumbers implementation. getNumbers implementation now only gets invoked on the deferred execution when the enumerator starts to be enumerated, or when the enumerator has moved next call. So, okay, all of this here in place. Now, this is a very simple example, but if we imagine that what we really want instead is getting that next item, perhaps is expensive. We might be reading a file. We might be hitting a database. We might be making a web service call. Or like in this example here, it was file IO is what we were doing. So this async enumerable, no problem, Andrew. You know where to find the recordings. It'll be up Monday, or you can catch it earlier on the Twitch recording. In the case of this method here, what it ends up doing is the next thing that it wants to read is coming out of an asynchronous method. So there's an await in here. Now previously, before the advent of async enumerables, there wasn't a good solution for this. Because move next is a synchronous method, you couldn't put an await in here. There was no way to combine await and yield return into the same thing, which was kind of sucky. So oftentimes you would end up doing weird things where you maybe make the call, do the await, and then do an iterator method for the other stuff, and yucky. So if we do something slightly different, let's come over here. Boom, async enumerable. Okay, so this is we're gonna get numbers, and I should probably change this async. Right, methods can't differ. Method overloads cannot differ only by return type. Okay, so now we come down here, and it goes all methods need to do a thing. So we're gonna do something really similar here. So we'll add in the precondition check. So just like with enumerable, you still have that concept of deferred execution. The difference being that the move next is now going to be asynchronous. So, and let's pretend that down here we're going to do await task.yield. And I'm just doing this as a simple thing because I need an asynchronous thingy to await. This could be anything, right? This could be a task.run or whatever. I'm just going simple and fast. Okay, so we make this guy an async and enumerable, and we can write our code, at least in terms of the iterator method, pretty much exactly as we did before. So let's do over here. Boom. And we'll do async deferred execution. So get numbers async, and I'm going to need to make this test async as well. Await async enumerable. Let's see, get numbers async. I did it. Oh, haha. So there is no await on this. Got it. Elements are written synchronous one by one and read multi-threaded many at a time. Is that right? Not quite. Let me finish going over this. It's technically read one at a time. And that may sound bad, but it's not. I promise. So rather than get enumerator, it's get async enumerator, which means this guy becomes async enumerator. And I'm trying to remember, I believe this is an await using rather than just a regular using. And then this becomes move next async, I believe, is the magical thingy, which means this becomes an await. So again, the alternative here is, and I'll just uncomment this to show it. Under the hood, you're getting something more akin to this, but practically speaking, in your code, you typically write this thing up here. This down here is just being shown as an example of what's happening under the hood to kind of punctuate where code is being executed. So, and then right here, it's just I'm gonna comment this out just for to make the point, and then this should show. Okay, so once again, our precondition check happens immediately on this initial line. We return back out, and then down here we get the enumerator, and as soon as we call await move next, now we start going through our iteration. Just like the enumerable did, the big difference though is now we have, with an async enumerable, we can use await and yield return at the same time. So what this ends up doing is allowing not multi-threaded, but different threads to go and get each of these items. So this guy awaits, and you'll note it doesn't actually kick back an item right away. This thing just returns one item, and then something goes boom. Or did I miss something? Did I hit a, oh shoot, my fingers are on the wrong, hang on, sorry. Fingers on the wrong button, I hit F5. Okay, so step over, step over, step over. We get into here, great. We step in here, we call, oh, Now I'm in the wrong method. Let's debug the asynchronous one without F5 this time. Okay, so we get our async enumerable, great. We come down here, get the enumerator, call move next async. This guy goes in, we await something, long running task, yields return. And my debugger really insists on not letting me step back out to the, I'm gonna just put breakpoints up here because apparently it just really wants to auto run. I don't know why step into, step out are not working the way I would expect. Okay. So we get the current value at 0, great. Move next again. Once again, start iterating, async and await. So the code looks to run synchronous. Functionally, it is executing in the exact same order as our synchronous version. The only thing that has changed is because this is now an asynchronous method that can be awaited, the task that is going to process it can be different. And more importantly, the code that's doing the iteration. So when you do a wait for each, your code, as it's getting each of those items, that thread isn't blocked waiting for the retrieval of the items. You can imagine if you're iterating over a database or records in a database and pulling them out one at a time, getting the next record, it's going to take a little bit of time. Not a lot, but it'll take some time to get it back out. In the synchronous version, you're blocked waiting for that record to come all the way back. In the asynchronous version, your thread gets freed up and free to go do other things until that next record is put back in. So it's not necessarily written synchronously and read multi-threaded. Functionally, it's still one guy's putting it in, one guy's taking it out. One in, one out, one in, one out. There's not necessarily the concept of fan in, fan out, as a lot of times people will describe it, where one thing's coming in and multiple things are processing it on the way back out. This is still one in, one out, but with the async and await, it frees up the calling thread to go and do something else. And I'm using the phrase calling thread kind of intentionally there because most of the time we don't care. In a WPF app, we care a lot because that calling thread could be the UI thread. So unless we've done something to intentionally get ourselves off of the UI thread with either configure await false, a task.run, similar, in order to intentionally get us off, that calling thread could be the UI thread and we don't ever want to hang it, which is why using the await is so nice. It frees up the UI thread to go back, process user, key press events or whatever, come back later when we've gotten that next record that we want to process, which is what that async enumerable is doing. And so one other thing that's worth noting, when we talk about tasks, we're almost always talking about multiple threads. And unfortunately, tasks were usually sold as a way of saying, hey, look, we've got this easy way of dealing with multiple threads without actually dealing with multiple threads. Under the hood, what happens is there is a background worker pool, and that contains some number of threads. It'll depend based on your operating system, the runtime. I'm trying to remember how many different ways that thing gets configured. It'll have some number of threads in it. And it may add threads to the pool over time, depending on the workload that it sees. Effectively, the runtime manages it. You don't need to worry about it. And it's what's actually processing those tasks. So when we talk about, even though tasks are going to be run on different threads, tasks themselves are not necessarily, don't correlate a task to a thread as a thing. A task is usually best thought of as a unit of work, ideally a small unit of work, that will be run on some thread, and we don't have to worry about it. In the last stream, we discussed cases where the work for the thread is too small. It does not create a separate thread for the work and does the work on the calling thread. Can this also happen here? So there are specific cases where that is. So let's look at that real quick, because I think think unfortunately that was the test down here that I deleted. I'm gonna just copy it real quick. Because I believe that was this test here that we were. And I'm just, here, let's put you off in your own, you can go live in your own file. Public class task test. We'll just put it here. So this was I think where we had that discussion last week about when there could be a separate thread managing the work versus not. And so the key case to know when you're writing asynchronous code with this await is your function gets kind of split apart into two parts: the thing above the await and the thing after the await. And obviously this is a recursive algorithm, so it's going if you've got a bunch of awaits. But the await may not actually cause a callback to occur. So when you hit an await keyword, there is a bunch of stuff that happens, because you'll note down, if these lines here are kind of moved into their own function, this guy is still referencing variables that existed in this thing, the thing before the await, in this other function. So there's under the hood, there's a class called an execution context that is responsible for kind of bundling everything up, keeping track of that state, and dealing with making sure that these variables are repopulated once that await completes. That adds overhead. Any sort of bookkeeping adds time. And so in this case, if the task is already completed, it'll immediately just continue executing synchronously on the same thread. So last time what we saw is that T1 and T2, I can rerun this test here, are going to be the same thread. So your question there about can we hit that same situation? So the answer is yes. So if we go here, right, and I'm just going to do int thread ID gets thread. Come on, give it to me. Nope, stop helping me. Thank you. Current thread, manage thread ID. So right here, and I'm just going to put a breakpoint here, and we'll just look at the values as they come. Stop my flow of questions if there are too many. There is no such thing as too many questions, Justin Bieber. I would rather be answering questions. At least then I know I'm talking about something that people care about. Okay, so first iteration down on the breakpoint, thread ID is 19. Hit F5, thread ID is still 19. Hit ID is now 18. And exit. Thank goodness. I was worried it was going to pick it up at the same time. So that was actually a beautiful example. So 3 hits because we were just iterating to a count of 3. And the first 2 iterations got handled by the same thread, and the third one got a different one. And this is perfect. I could not have asked the TPL to give me a better example to play with. So it can certainly happen that the same thread picks it up, because all of these tasks, anything that's before and after an await, those things are just thrown onto that background worker queue to get processed. And the threads in that worker queue, whenever one of them's available, it just grabs the next task, picks it up, starts running. That's great. So which thread is available to pick it up will be pretty variable. You don't have a lot of control over it. There could be other things that are leveraging the background worker pool as well. So like in the example we saw there, the same thread 18 was available on the first 2 iterations, and then on the third one, thread 19 was available to pick it up, and it just happened to work out that way by random chance based on which thread was it. So it is very possible that you can get picked up by the same thread or different threads, and so that is something worth keeping in mind. The task.yield gives us it. Task.yield effectively sets up everything after this await to say, yeah, throw that back in the worker pool, run me on whoever's next, which is a useful way to get yourself off of a UI thread. because it can get you off of your UI thread and just say, okay, everything after this goes down here. I personally prefer a task.run to be a lot more explicit, because people usually can grok a lot better that, hey, anything in the task.run, that's obviously being queued up for later. Now, if we take away this task.yield and rerun the test, come in here. Okay, so thread 18 for the first one. Come on, Visual Studio. This is not a hard evaluation. Okay, we're going to stop this and try this again. Let's try this. Get through here. Okay, thread 16. And I think I hit it. Thread 16, there we go. That's what I was expecting, because the await here, because there's nothing being awaited, these should all end up on the same thread. This effectively gives us back because it's not hitting an await, nothing's being kicked back into the background worker queue, it should always move through, go through there. How can you drink so much soda and stay in good shape? That is a question I get asked quite often, specifically by all of my colleagues, my wife, and anyone else who spends too much time with me. And the answer is so I say this slightly cheeky. I am cursed with my family genes. My family, or at least my father's side of the family, is very high metabolism. We tend to be able to consume quite a bit of stuff and not gain much weight, and my wife hates that because she's much more normal. Like the average person who, if they drink a ton of soda, they tend to have the predictable results from that. I'm cursed, and that doesn't really happen much. Okay. Great questions. So that is functionally under the hood how an async enumerator is working. Again, don't write your code like this. This is the code you write here. Oh, that's part of why I'm getting weird results. I've got the await for each uncommented too. So actually, I'm going to comment out this, because this is the hard way. We'll move this guy up here. So, and the key part with a lot of this is, in nearly all cases, you don't actually care about what thread is running your code. I said in nearly all cases. The exceptions are obviously the UI thread with some sort of desktop application. We care a great deal about if we are on, so we don't care exactly which thread we are on, but we do care about, am I on the UI thread or am I on some other thread? That we care about. That's an important thing to keep track of. Like ASP.NET Core applications, who cares? Like those ones, there is no real UI thread. We obviously don't want to hang our current thread. That's still bad. We'd like to free that thread up to go and do other stuff, because a thread that is hung is not processing and doing useful work. We would rather it do useful stuff. The other way I've described this to people in the past is almost if you think of a restaurant. If you imagine like you walk into a restaurant, there's somebody there to take your order that we'll call the people working in the restaurant are threads, right? So the person taking your order, great, takes your order, maybe puts it on a piece of paper and hangs it up for the cook. So that person is not standing there waiting for your order to be completed. They said, hey, I'm going to pass this work off, effectively a task, make the food, and I'm going to return back to, helping the next customer, which is great. That's what you would expect. You don't want your workers sitting there waiting for something to be processed. You want them actively doing useful stuff. The cook gets that order, picks it up, and says, oh, okay, I'm going to start making some food and start working. Now, in this hypothetical restaurant, our workers can only do one thing at a time. There's no concept of multitasking. That doesn't happen. But the cook starts doing the work, makes the food, gets everything on a plate, yells order up. One of the other staff then comes in, picks that up, and at that point, that worker is able to then, I should say the cook is able to go back, pick up the next bit of work and start going. What's it? MRA Dam? Thank you for the follow, and welcome to the stream. We are having wonderful times discussing tasks in C# and threading and all that joy. But your cook is now freed up to go back, start working on the next order, make some more food, and everything runs smoothly. This is the beauty of what async and await gets you in C#, is that ability to have your workers continue to work, rather than customer places order, the person helping the customer takes that order, hands it to the cook, and then sits there and waits. Which is oftentimes what you see people when they write code that does like task.wait or task.result. That's what you're doing. You're telling the worker, stand here, don't move, wait till it's done. And that's bad. It could also run into a deadlock situation. You could imagine if the cook were then to ask the person to say, hey, could you hand me the salt? That person can't hand them the salt because they're waiting for the cook to finish the food. And the cook can't finish the food because they don't have salt. And that's bad. Because then nobody gets their food and the workers are deadlocked and nothing happens, everything stagnates and badness happens. Boom. So don't do that. Task.wait, task.result, both of those are code smells that should be avoided. Let me see if I can find it real quick. So there's actually that Stephen... Definitely, you need to speak on the topic of deadlocks and single applications. Yes. That is not the link I wanted. I wanted this one. So Stephen Taub here. Is there a way I can just click on him and get his other blogs? Okay. Let's see. So it's Stephen C# async over sync. He's got 2 blogs. Yeah, these 2 here. These ones are pure gold. Absolutely pure gold. So if you find yourself feeling like you need to do task.wait or task.result, give both of these blogs a read. Because he goes into a lot of the details on sort of how asynchronous works and why task results there are small use cases, they're getting smaller every day, where these types of things are still needed. And they usually come down to you're using some third-party library that hasn't updated in a while, doesn't have a concept of async, and you need to wrap it. Doesn't happen a lot, but occasionally I still run into it. I ran into one earlier today on a legacy project. They still exist. They haven't died yet, unfortunately. Or you maybe run into somebody who's not as familiar with async and await, and they just weren't familiar with what they needed to do. They didn't realize they should be using await all the way up, and problems occur. So, okay. We were doing something before I got onto that. Stack pop, stack pop, stack pop, stack pop. We were writing a unit test. Or I should say we were fixing a unit test. Oh boy, that was like 18 levels deep. That was fun. Okay, so let's go breakpoint. Okay, so a couple comments on debugging, because this is something people should know. So when working with tasks and going through all of this stuff, there are some awesome things under the is it debug windows? Where is it? Okay. Other pro tip, Visual Studio 2022. This search bar, this is your best friend. This is the Windows, your start menu and you can just type stuff in to find stuff. This is that for Visual Studio. So if we go with task list, no, not task list. What is it? The task. There is a debug one. that shows up for, it's not the threading one. Oh, where are you? I'm going to find you. Because task list is just things to do in the code, but there's one for actually viewing the async stack. Have you thought about making your own blog or information resource where you would share useful things or write short posts or reviews? Yes. Let me just check the link before I share it. I'm pretty sure this is right, but remembering my own links is hard sometimes. Can't remember if I put an S on the end of it or not. Thinking. There it goes. So, yeah. So this one here, it will redirect. So currently it is under, most of the time when I write blogs right now, it just gets posted. So I currently work for a company called Intelitech. Don't mock our website too much. There's a redesign that's almost completed that is going to make it, it's going to fix the performance problems. Let's just say we had WordPress problems. I'll sum it up with that. But you can find a lot of the stuff that I have written. I like writing blog posts, and oftentimes I feel a little bad because the last two that I've written, I've ended up deleting because the technology on which they were written towards was obsoleted and killed. So it didn't seem like a worthwhile blog to continue publishing. But yes, I definitely, if I find myself writing things out, because some people, my preference is if possible to make a video about it, because oftentimes it's easier for me to talk and explain. But there is something to be said about having something written down, because oftentimes that's a lot quicker. You know, people can do Control F, find things, move around, that kind of stuff. It can be a lot nicer. So if you are interested, that is currently where I am posting stuff. And if my blog ever moves, hey, Adam Billivan, I'm sorry, I'm probably butchering that last name. Thank you. If you are interested in seeing stuff that I write, they go here. Again, a few of these are a little old. They've been doing a website redesign the last couple months, so things have been, they've been blocking new blogs from going out. Yeah, last name. Sweet. But that is expected to be out soon, and then more blogs will continue to flow. So, but just like with the videos, if there are concepts people would like to see something written down on, I'm very happy to do that. Oftentimes with blogs, people struggle for, well, I don't know what to write about, and I'm usually encouraging my colleagues, just as we're running into problems throughout our day jobs, oftentimes those problems can be genericized away from the project that we actually experiencing them in, and just share it, because oftentimes those are what people are hitting. If we're running into them, somebody else is probably running into them as well. Okay, so I wanted to find that debugger thingy that I did not find yet, and let me find this guy. So I'm going to debug. Some Windows and studios are available only at startup, or in debug are not visible in other cases. I think you are correct, because like the modules window is one of those examples. Okay, so let's come in here, debug Windows. There we are. Now we're talking. Okay, so okay, this task window. So debug Windows task. This is the one I wanted to show. So some people are familiar with the threading window, which is another useful one, where you can take a look at your threads. And inside of a WPF application, I will oftentimes use my threads window pretty much to just hunt down what is my UI thread doing. I don't care too much about worker threads. You can see several of these are thread pool ones. These are going to be ones that are likely picking up tasks to do work. But oftentimes I'll use the threads window to just say, you know, at this point when I'm running my app, I always get a hang, right? You get that little, you know, white screen in Windows or your app is not responding. This is bad. Oftentimes, I just hit pause in my debugger and go, okay, where's my main thread? What is it stuck on? That's not good. But the problem with threads and interacting with tasks, because tasks aren't threads. Tasks are units of work that will be run on threads. And so usually what's more helpful is taking a look at the running tasks or the active tasks in here and jumping into, because these guys here, and in this case, because I'm just debugging a unit test, they are not likely to get me into useful stuff. But this can be a much easier way of tracking down what work is happening. Multi-thread debugging in Visual Studio is another great topic. I think, let me double check. Yes, I have that on my list already. I was not joking. I did save the suggestions I got from you, Justin Bieber. They are on my list to cover. Because honestly, a lot of these tools could be covered in depth individually. But just a few things that are worth calling out to making sure that you're available on, that I use all the time. This is definitely one of the ones that is worth taking a look at, especially if you're trying to figure out, hey, what is doing this? Because quite often, especially when you get a lot of tasks, like you get a bunch of tasks.runs up and running, it's like, I don't know what's going on. Where did they go? Why is my data changing? Who's doing that? It's sort of like when you let's go back to my restaurant example, rather than just a couple workers, we now have a dozen, and now it gets hard to figure out, okay, who dropped the piece of paper? One of you did this. Who is it? This is the list. So that is definitely something to be aware of tracking down. Okay. Stack pop. Unit test. That's what we were doing. Okay, because we were going back to actually trying to make these. Let's see, test. I'm going to move you. Karnak not running. Oh, Karnak crash. Bad Karnak. Come back up. Be happy again. You there? There we are. Okay, so now you see the little shortcuts in there. For people who are unfamiliar in Visual Studio, this teeny little icon that you see floating over here, that's not what we're going for. The little paintbrush, there, that guy, that is a helpful icon to keep your eye out for. The other one is if you see the light bulb. What was I on a second ago when I triggered the light bulb? Was it there? Yeah. You see the light bulb? That's another one to look for. These are Visual Studio autocode cheats. These are awesome. And control period. I used to tell people that control period was the autocode button, and then they added IntelliCode where the AI literally tries to guess what you're going to write, sometimes with creepy level accuracy. But if you see any squiggles, oftentimes the easiest thing to do is literally put your cursor on it, control period, or you could click the button, and it will happily tell you, hey, by the way, this old API is going away. You should use this instead. It's like, oh, thank you. Or sometimes it's not necessarily going away, but hey, if you want to be cross-platform compatible, yada, 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 this is the newer API to use. So there is a lot of stuff built into these. And another fun topic that might be interesting if people want to see it, you can build your own. They are called analyzers. They are cool. And you can do some pretty sweet stuff with them. So like inside of XUnit, you'll oftentimes, if you see a little squiggle underneath an assert, for example, if I do int foo equals new, right? So I create an array. If I do an assert, I think it is true. How do I trigger this? Assert true foo.contains. I think that'll trigger it. Yeah. So like this squiggly here, XUnit ships with their own analyzers, and they detect that, hey, if somebody does an array.contains or a list.contains inside of an assert true, that's not the best way to do the check. Because when it fails, all XUnit can give back to you is a message that says, hey, I expected true, but I got false. And that's not really helpful when the message you actually want to get is, hey, your list didn't contain the number 1. That would be better. So XUnit has an assert contains, which is a much better assert to use. And so their analyzer not only flags the mistake, but offers a helpful code transformation to fix it, which is cool. And then you could, if you want to go crazy mode, you can say, yeah, just apply that change everywhere in the entire solution. Fix them all. I usually like to review them, but to each his own. So if people are interested in seeing analyzers, I've written several. There's plenty I would love to write. They're quite fun. They're a little complex because you kind of have to do meta level programming, but because you have to write code that reasons about code as the text exists for the code. If reflection is 1 level, this is like 2. Okay, so the whole thing, all of that, just so that I could, nope, don't extract a base class, move to a different file. Thank you. Okay, so we were going back here, and this guy is entirely failing. So we'll recall, so in this case, our unit test is testing the onRefresh method. The onRefresh method is starting a task and calling load themes. And inside of load themes, it is invoking this, or I should say, it is awaiting an async enumerable. So we've got an async enumerable similar to what we set up over here with our get numbers async. In this case, it's just retrieving themes. And unfortunately, it's throwing a no reference exception. Oh, and actually, let's show that no ref. Let's show that no ref. So if instead of all of this garbage, we just did return null, this is bad. Don't do this. This is not what you should do. Right? Get numbers async enumerable methods should not return null. But in the event that you are unfortunate enough to run into that situation, we run this test now. What we should see is this guy fall on his face with a no reference exception. Oh, I wasn't debugging. Let's try again. He went red, so that's a sign that it started failing. Oh, and I've got a breakpoint, so that'll be fine. So we'll do that. Deferred execution triggers. And then we get a no reference exception. So this is the same situation that we have here. Is the asynchronous method is kicking back a null, and the await can't do anything with a null because it can't do the get async enumerator effectively back out of it. There's nothing there. It got a null. Null is bad. Don't do that. So that's this call here, the one that you don't see up here because the helpful compiler is doing it all behind the scenes for you, is the null. So that is the bug, and now we need to fix it. So we go back here. Okay, so with mock, the easiest way to handle it is theme manager. So by default, it's going to return the default return value, which is null, which is not helpful. So we want to tell it to return something different. X.get themes, right? It was get themes, not get. Get themes is the one that's breaking us at the moment, so that's the one we're going to populate. And then I believe this guy had no. Rather than just dot return, I believe there is a returns. Does it not have a? I thought there was a helpful overload for async enumerables. Let me just look. I could have sworn mock async. Yeah, task value, task, blah, blah, blah. Mock an async in this method, iterating with async enumerables, blah, 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 blah. I don't really want to have to gen one. I'd kind of prefer if it would just do it for me. Yeah, those are all fine, but those are all async methods, not async enumerables. Okay, so apparently this needs to be my next blog post, is mocking async enumerable methods, because apparently there's not a good tutorial that shows up on the first page of Google. Unless somebody wants to beat me to it, by all means. I do not opposed to that, but there needs to be a more helpful example. Okay, so there's a couple ways we could go about doing this. Okay, we're going to do the manual approach first, and then we're going to make it pretty. So static I async enumerable, and I'm going to do a T because we're going to refactor this later, and I know what's coming. Empty async enumerable, generic of type T, and then I think what we can do is just empty. No, because it's going to be unhappy. So yield break. So I talked about yield return earlier. Yield break is effectively, so rather than move next returning false by getting to the end of your method, the other way to get move next to return false is to yield break. Effectively tell the enumerable, all done, I stop. Oftentimes you yield break inside of a, like, if you've got a while true or something where you just want to keep iterating, but there's some kind of complicated condition that you want to maybe break out of, something like that. Okay, so you're just unhappy. Oh, fine. Be more happy. Blah, blah, blah. Okay. So this guy is currently unhappy because he realizes there's a problem. And so we're just going to do, oh, no, get themes is a theme, not an int. We're going to do that. We'll just ignore this. So this probably fixes our, except for in this case, it was expecting 2. Well, this 2 is on the property value changes. So the only issue here is we were expecting 2 property changes simply because we were expecting there to always be a theme. We should gen up a fake theme, because this is testing a case that doesn't realistically exist in our app. So let's make this a new one. Worth mentioning this, I think I commented on the unit testing talk last week too, but this is so different unit testing methodologies have different blind spots and weaknesses, and it's important to know what those are, rather than just trying to stick with one for everything, because they all have blind spots, and so you kind of need a nice mesh to get good coverage. So the disadvantage of mocks or anything of that nature that kind of fakes out an interface for you is that typically they are only as good as your test makes them. So what I mean by that, in this case, this theme manager mock is only as good as the setups that I do on this guy, because I could make this thing behave very differently than how the real one in my app will behave. And so oftentimes people who are really heavy into mocking for their unit tests, that's where the bugs creep in, is right at that layer where their mock behaves a little bit differently than their real one, and maybe their code didn't account for a case that the real one had or similar. So those kind of subtle things, that's the blind spot of mocking, is they are only as good as you can make them match. So, not with that said, they're a powerful tool to be used while testing. Don't take that as they're bad, but it's important to remember that in the back of your head. So we want to create a theme. For the purposes of this, I think what we can do, will it let me get away with, something stupid like this? New theme. Trying to remember what I need for a theme. Just a couple strings. Yeah, that's what I was afraid of, is that you wouldn't. Trying to avoid pulling in extra NuGet packages, but we might need to. Let's see. Small question. Can I safely start 1,000 tasks and tasks when all? Will it distribute the work safely in terms of creating threads, or do I need to manually limit work blocks, number of cores -1, etc.? So great question. And so Justin Bieber is kind of alluding to. So there's a whole bunch of the science part of computer science of figuring out how many threads is optimal for an application to run on. And kind of a rule of thumb that gets used often is because a core inside of your CPU is really the bottleneck. Like, no matter how many threads you create, at some point the CPU is where the rubber meets the road. That's the thing that's actually going to do the work. So oftentimes you'll see people use, one second. You'll often see people use the number of cores as kind of that ideal number for how many threads you can have, because at best, physically on your machine, when your CPU clock is ticking, that's the best throughput you're going to get. But the question of can I start effectively, I'll genericize it, any number of tasks, and trust that the TPL, the task parallel library, the namespace that contains all of the tasks and all of that magic to distribute the load? The answer is yes. So under the hood, because a task is not a thread, the goal with tasks is that you can completely not think about threads and just use tasks, and everything will be golden and happy rainbows. That's a lie. But in a lot of cases, they make it easier because you have to think about threads less. I hate when I hear people say, oh, you don't have to think about threads anymore. It's like, well, it's not completely true. That's a great way to get yourself into trouble. You think about them less with tasks, which is good. So yeah, if you spin up a whole bunch of tasks with task.whenAll, it will distribute that work. So depending on how you do that, like say you have like a task.run inside of a for loop that just creates 1,000 of them. Every call to task.run is basically going to enqueue another task for the pool to process. And then the task.whenAll, all that ends up doing is taking that list of tasks that you have and watching for the state of those tasks to be completed. And it was good that you called out whenAll, not waitAll. So and I should mention this. There are small but important differences between waitAll and whenAll. So, in case, let's see if I can do this quick. Aha, got it. So the key difference is that return type right there. WaitAll is void, and if you look at whenAll, it is an awaitable task. So waitAll is another way to kind of do that force asynchronous work down to synchronous. And so if you're using it, you need to be very careful and go read those Stephen Taub articles. But with the task whenAll, because like I said, I imagine maybe you've got a for loop that does a task run, spins up a bunch of tasks. All of those things are just units of work. And whenAll is just watching for those tasks to have their to be completed, so that it can so that its task can be returned. So the task that whenAll uses, its job is to check the other tasks. So this starts to get very recursive very fast, which is awesome. And the best part is there's, n number of threads, depending on your system, that will be processing these tasks. So how quick it goes can be variable. So you don't have to worry about it. The one area of tasks where it is, and I should call this one out too. The one area of tasks where you do want to think about threads. Tasks are designed to be short units of work. And so you can imagine that if a task was going to take a long time. So let's imagine in our restaurant example, we were to assign, hey, we need to mop the kitchen. That's a task. If we were to assign that to our cook, he would be mopping the kitchen the whole time and not making food. And mopping the kitchen can take a while. And so we probably want to assign one person to do that, and get a dedicated individual to come in and clean that up, rather than trying to use our current pool of people. So to say that another way, sometimes we want to strongly hint to the runtime, hey, this task here is a little bigger than the other ones. You probably want to assign someone specific to this and not use one of those pool things, which not guaranteed, but will often cause a new thread to be generated. So our workers, we're representing our threads. If you tell a task, hey, this is a big task, you might want to assign somebody to this. That will oftentimes get your task run on its own thread. Now, the nice part is, once again, you don't have to deal with the threads. You don't have to deal with the exception stuff. Those bubble up nicely for you. That's wonderful. But let me double check, because there was talk of it being added to task.run, but I don't think it was. Yeah, it's not there. So task factory, start new. This is task.run was not initially in the API when tasks first launched. That was added as a convenient shorthand. And you'll note on task factory start new, a lot of these overloads look remarkably similar to the task.run overloads. And the task.run overloads are what you would use nearly all of the time. The exception is this guy here has an additional parameter on him called task, creation options. And under these task creation options, there's some more advanced situations that you can set up on here. And I won't necessarily bother to cover all of these unless people have use cases for them. Most of these don't get used. These are kind of very, very specific use cases. Most of the time, you do a task run, you don't worry about it. You let the runtime handle it. It's going to probably be smartest. However, where is long running? Yeah, long running is the one that often gets used. So this will this is often what you want to do if you have a bigger task that needs to run, something that you know is going to eat up a bunch of time, and you don't want to have it occupy one of your thread pool threads. Now, it's worth knowing that you don't necessarily want to do this in too many cases, because threads are expensive. Like, they're about 1 megabyte to do new thread. That's huge. That's a lot of memory to allocate. They are big and slow, but they also do work. But if you have a big job that needs to be done, like say mop the whole kitchen, well, that's a situation where, yeah, I don't want to take one of my existing workers. They're doing a great job with their kind of small tasks around this restaurant analogy I've got going. Let's hire someone new to come in, and their job will be to, clean and mop the kitchen. And so we're going to mark this task as long running to strongly hint to the runtime, hey, this should probably be put in its own thread. This is going to take a while. Please don't have one of the regulars do it. Let the regulars continue operating the other ones. So be aware, task factory, start new, the task creation options of long running is potentially what you want. So, but again, you should use it somewhat sparingly, just like you should allocate your own threads very sparingly, because they're big. So use it only when the job calls for it. Okay, so I wanted to create some new themes. And let me do, there is a returns async thingy, but I'm pretty sure it's only going to show up on the other APIs that are async. So, like delete theme was async. Oh, but that doesn't return anything. How about create theme? That'll work. I'm pretty sure there's a returns. Oh, hush now. I know you're unhappy with me. I get it. I did bad things. I don't know. No. Hush now. I just want to look at the API. I don't want to. Yeah, there's the returns async. There's no returns async enumerable. Okay, well, we're fixing that. Build that sucker. Okay. So here's what I'm going to do. We're going to write it manually first, and then There are NuGet packages that will do this as well, but I'm gonna write it out. This is like, I sometimes get hesitant to bring in a whole NuGet package when I don't actually need it. So really what I want to do is I just want to instantiate a new theme. So get themes. Okay, so what we're saying is on this mock, when get themes is called, we need to return an async enumerable. We would like to return a theme. So we're going to do, what did I just call that thing? As async enumerable. And we're going to do innumerable of t items. And then we will do for each var item in items. Scroll that guy up. See, this is what I mean by autocode. The AI has intelligently figured out that that's what I want. So you hit tab and poof. IntelliCode is awesome. Okay, for people who haven't found the auto button for it, what is it? IntelliCode. There. So underneath your options, for a while it was hidden behind a preview feature flag, but you should have this on and set to default, because you can disable it if you don't like it. But in fact, you know what? We're going to just always enable it, because oftentimes what you'll see on default is on new projects or solutions, you'll get a little yellow bar at the top saying, hey, would you like to turn it on? And the answer is yes. Always yes. Okay, so we're going to do this. It's unhappy that we have an async method without the async keyword. Same question about parallel for each. Oh, another good API. So the parallel class actually existed before the TPL as well. And .NET 5, I think, added in a few additional overloads for it. So there's parallel for each and parallel for each async. In most cases, you probably want the async one. It depends a little bit on whether you're talking about tasks or if you've just got a synchronous method that you're trying to spin across. But yes, parallel for each will handle it for you. You don't have to worry about it. So yes, it will allocate work out efficiently. There is on the parallel for each, and I'm doing this from memory, so bear with me. There is an overload in here that has an enumerable as well. Where is the overload? Parallel options. There it is. Parallel options, and I believe, is it new parallel options? I don't use this API very often, so I'm struggling to remember exactly what it looks like. So yeah, this guy here. So you can feed it a parallel options instance, and there is a couple fun things on here. This max degrees of parallelism. I'm probably butchering the parallelism. It's like trying to say banana. You can never remember how many nanas go into it. If you want to kind of limit how many are going up, like, yeah, I'm gonna put 1,000 things in here, but let's only run 4 at a time. We don't want to just chew this thing up. You will note that if you throw like a big list at this thing and you don't like limit it, it will pretty much run up to like that num cores limit, and if you're on a laptop, you'll hear the fans go as up it goes. So it will push a parallel for each loop is a great way to get max performance out of your processor. So it will allocate it intelligently and handle it, but also note that its definition of intelligently is everything the system's got. So if everything the system's got isn't desirable, dial it down with this class. Okay, let's go here. Okay, so that goes there, that goes there, that goes there. Okay, so we wanted as async enumerable, and so we're going to do something like var themes gets new theme, and then we're going to so we'll just new theme, and I think we can get away with just empty in both of these cases. And so returns we want as async enumerable, and then we will pass it our themes. Dippity booyah. And then test pass. Test pass! Yay! That was easy. Okay. The one thing I don't like is I don't want to have to write all this every time. This is way too much work. Way too much work. So we are going to write our own little extension method class. Oh, actually, hang on. We're in latest file scope namespace. So if people aren't familiar with it, C#10 added file scope namespaces, purely a stylistic thing, because pretty much all of, or I should say all, nearly every C# file you will come across has exactly one namespace declaration in it and stuff inside of it. If that is you, and it probably is, statistically speaking, in C#10, you can put a semicolon at the end of your namespace declaration and drop the curly braces. Reduce the indentation, you got a little more horizontal space. That's it. The feature's no more complicated than that. The only time you have to go back to the old namespace declaration is if you were on an older compiler. So this is something you can actually use and target non.NET 6. So you can be targeting old .NET framework as long as you're on the latest compiler. So you need to be on VS 2022 or .NET 6 SDK. And you can leverage it because it is just syntactic sugar. That's it. Okay, so we want to do that because I don't want to have to write this every time. What I really want to write here. So this is what I have now, but what I would really like to write is returns async enumerable, and I would like this line of code to work, and more importantly, I would like to be able to have this line of code work too. So this is oftentimes when I'm prototyping out APIs, I will often just write the code as I want to do it, and then I will just beat my method signatures into submission until I get the API I want. Question: spaces or tabs? Ooh, I think you're trying to incite a flame war. So I will go with this. So first of all, the arguments that go back and forth. Tabs, usually proponents of tabs argue for them because they have configurable widths, perhaps for accessibility reasons. For people who need things really large, that can be really helpful to be able to set them. Spaces are consistent. Oftentimes, people who are all spaces will say, hey, we also have better tooling support, like GitHub. Oftentimes, if you have things that are tab spaced, what looks nice on your system may not look nice there. So the tooling support for tabs versus spaces definitely favors spaces, at least current environment. Current environment with .NET tooling, so Microsoft-based stuff. I'll say that. My strong personal opinion is you're not allowed to pick both in the same file. There is a small group of people who argue for both, and I really have trouble grokking the argument. And I'm trying to remember what it is. Tabs for indentation and spaces for alignment or something like that. That position I completely reject. Do not like it. I've worked in code bases that were tabs. My default setting is spaces. Oftentimes I oftentimes turn white space on. I just know that oftentimes it gets a little busy and people don't like seeing this. But if I see somebody using tabs, I have no problem with it. I probably won't even comment in a code review for it. But my strong position is you have to pick one and be consistent. You don't get to go back and forth or mix and match. That's just, that's horrible. But my default setting is spaces. That's that's where I land, I guess. So, and like I said, I can at least respect the tab people. I would like to think that I understand the position and the benefits of it. I just prefer not to. The lack of good tooling support it feels like a big boat anchor, and unless I'm working on a team where that is a big concern or necessity, it really doesn't bother me that much. The other reason it doesn't bother me too much is because some people worry that, oh, well, you have to pick one and you have to be right early on because otherwise it's really hard to go back and change later. Really? I have a hard time buying that. One, it's not hard to PowerShell regex your way back into the other one. That's not hard to do. The other thing is with an editor config and the .NET format CLI tool, you can switch back and forth intelligently even. So it's sort of like how people used to have large debates on line endings in files, because you would get people on Windows boxes and Linux boxes, and there was never a good agreement on line endings until finally Git took care of that, and now everybody gets line endings that are native to their system, and it just goes back and forth, and the tool supports it. I kind of wish that the tab spaces debate would just get resolved that way, and that the tool would basically allow people to configure locally. Do I want tabs or spaces? On commit, you can check it in whatever standardized format you want, but let the tool do that conversion. A former colleague of mine had a pie-in-the-sky dream, and every so often I go back to thinking about if I would want to take a run at implementing it. But he had this wish that, and for him it was for code reviews, that people could view code in whatever stylistic format they preferred. And that would mean things like, rather than the curly brace down here, curly brace up here. Because functionally, that doesn't make a difference in C#. It really does. Like, there is no, stylistic is the only reason to move that around, right? You can make a readability argument, maybe. But his pie-in-the-sky dream was to have some tool where everybody could code review with the style of their choice, so that style wasn't then part of the review, and it was all around the functionality, how did you name things, is your algorithm and code readable, and that kind of thing. And little stuff like spacing and braces just got thrown out the window. So if anybody builds that tool, I want to hear about it, because I wish that would be how a lot of those debates got solved, is the tools just took care of it, and then the debates don't need to happen. Everybody can develop in the style that makes them happy, and then more importantly, the code gets checked in some standardized format. Great. That way, it can be all clean and whatnot when it's in the repo and all of that. Okay, we're going to build these two async enumerable methods. Okay, so what I want to create is some extension methods. So public static class, let's go mock extensions, public static. Okay, so now here's where it's going to start to get fun. So we want to duplicate effectively what this thing is doing here. So this is going to start to look weird really fast. So the key thing to note with these mocks is the return methods actually are not void, because you can, it has very fluency syntax, so you can daisy chain stuff onto the end of them, like verifiable. So we want to respect that in R, so our return type is going to be the same. We're going to do a return of tmock, because that's where this needs to land. Let's see, so the name of it will be returns async enumerable. So go ahead, include the, you'll figure it out. Okay, and so for starters, we've got at least one generic parameter, tmock, that we want to put in. That solves that. Why are you not finding I returns result? I literally just, here, I think these two are, I think you're confusing my IDE. Why are you so Whoa. I don't know why you aren't auto-finding that. So here, let me help you. Using that. Thank you. Okay, so it isn't, oh, clean up our usings. Oh, why is Karnak dying repeatedly on me? I don't know why it's crashing. Might have to reinstall it. I've run into this problem before. It gets itself wrapped around an axle and just loses it. Okay, so extension methods start with the this keyword, and then we have to indicate the thing that we are extending. So you'll note these guys here are just straight on it. So the type that this will end up being will be, let's see, the return from this setup. So let's download source. Oh, I guess, oh, were we debugging? Was that? We're not debugging. So it'll probably be this, and we may end up having to write some fancy stuff. I think we can actually probably get away with tmock here. Okay, so because what we would like to do is be able to, inside of here, we're going to end up doing the same, we're going to kind of wrap up what we did before. So I'm going to bring this guy out of here, bring him up here, I'll slap a. So one thing I usually will tell people as well, these access modifiers, so they aren't strictly necessary, right? You can go ahead and omit them. But I usually tell people when I see that in code review, if you don't put the access modifiers on things, I get to quiz you on what the defaults are, because they aren't all the same. So the default access modifier depends on the thing you're talking about of what it is. So for example, class's default state is, so this was public, but if I omit it, the default now is internal. This method here also had public on here, but if I omit it, it now defaults to private. So, and usually what I found is most people don't have the access modifiers memorized. So usually it's best to specify them. Be explicit. Because what I found is most people, I can't remember them anyway. Until I forget, I wanted to leave a question about T4 and code generation. If you're familiar with this technology, it'd be very cool if you made a training stream, as there's very little information, but the thing can be very useful. So I am familiar with it, and I have done some T4 in the past as well. So the one question I'll put back to you though is, are you tied to T4 for some reason? Because there are some reasons to actually still use T4, or are you just looking for code generation? Because if you're just looking for code generation, up to YouTube channel, there is a generator. I do have a source generators video. So and actually I will share a couple of these. So that the first one there is my introduction to source generators. So that was kind of me learning and going and doing. If you want to see it actually put into practice, these ones here. So there's actually several. I'm gonna link the whole search. The ones down here about either the XAML test source generators or the material design and XAML source generators are much nicer. Now, for the general outlook and consider the question. So for the general outlook and consider the question, make a static class with collection of WPF application colors and not access them from the XAML magic strings. Okay. So you might actually be very, very interested in this video here then, because this code, even though this video is old, this code has not actually merged into the material design library yet, but there is I go here. Oh, it must be out on my fork. This is the PR. Yeah, look at that. It's out on my fork, not on the main repo. So here is the branch. And you will find buried down in here, there is this generators project. So this is specifically, if you're looking for WPF related bits, this theme brush generator. So this is taking in and parsing out. So in this case, it is reading in the XAML files and generating out a C# class with relevant data. Because for the material design project, and I need to get back to this, I ran into a theory question, and I couldn't decide what I liked, and so I kind of shelved it for the moment until I could decide what I liked, and I had the choice between bad and yucky. But this actually gives a pretty reasonable example of showing how to generate out those theme colors in this case. So it is reading in a XAML file, generating out a C#, and it is generating out properties where it's setting up the colors. So if you are interested, the only other thing to be aware of that may not be immediately obvious from looking at this, let me just check the code to see if there's anything else worth noting. Yeah, so there's these guys in here. That's fine. That's fine. There is, and to be clear, these are not fully complete. They're functional, but not complete. So they aren't running through everything. But the down here in the CS proj, because by default on a source generator, you only get access to the C# stuff. If you want access to more than that, where is it? Where's the additional files bits? Where is it? It's been a while since I was playing with this, so I'm trying to remember. There is something for the additional files that has to be set. So specifically to have this bit here read from these additional files to get populated, there is something that no, not in the user, in this repo. That's a bold-faced lie. It's because you aren't searching this. Let me look at where, because it would have to be either in this CS proj, which it's not, or it would have to be in the themes, or maybe it's in the colors project. That doesn't have a reference. I don't see the generator referenced in the colors project, so it's got to be themes. And it's got to be in the CS proj. Oh, I guess I do have some targets files. I should check those. Documentation, package references. Output item type analyzer, reference output assembly false. Ah, here they are. These guys here. So if you want those additional file things to get passed to your generator, you have to set those up. Otherwise, your source generator is only going to get access to what's called the AST, abstract syntax tree. So it's the C# compiler or Roslyn compiler's view of the source code. You get access to the objects that the compiler was going to use to generate your DLL. You can't manipulate, and this is there's some limitations with source generators. You cannot manipulate the existing code. You can only add to it. So With that said, that just means that you have to set up your code such that you leverage like partial classes, partial methods, that type of thing, so that your generator is only adding to it. It can't mutate existing code. So there are some things. So that's the big limitation with source generators. So it's additive only, and if you want to have it parse like a CSV or an XML or similar, you have to actually set those things up as additional files, and then you can read those from that additional files in your generator like this one's doing. So that's the magic. I just can't remember where the heck it was. But yeah, once you create a source generators project, it does need to be here. There is the only other limitation to be aware of is source generators will not work on really old .NET frameworks. I think you have to be on at least .NET Framework 4.6.2. Any of the supported frameworks, source generators work on it. But if you have like some old legacy code that's well older beyond Microsoft support, you might not be able to use source generators. So there is a minimum version for it. But it's fairly generous. I think it's .NET 4.6.2. Yeah, 4.6.2. Because I'm pretty sure I set this project to the oldest thing that was supported by Microsoft. So, for what it's worth, if that's helpful, like I said, I could certainly do something on T4, but a lot of what T4 was used for has been replaced with source generators, because T4 was a little more limited in what it could do. Whereas source generators, because they can look at the syntax tree, they can be pretty smart. They can be packaged up with NuGet and just deployed into an application. So there's a lot you can get away with. Okay, so we're going to do this. Okay, so we need a mock here. And so returns is async enumerable. Okay, where were we at? So this is, why did it drop the, so in here, I'm gonna end up with something like this. So this needs to be a guy here. So what we're looking for is the incoming parameter here. So the easiest way to do this is go var m gets and break these two calls up, and then this is m var n equals, and then what we do is we just replace the var with the explicit type. Okay, so the input value of what we want is a setup of some kind. So this guy here really needs to be a setup, and so this is going to be t mock. This is going to be async enumerable of t. So we're going to add a second generic parameter here. That'll go like that. Tmock must be a reference type, so I think we can auto code this. Nope. Where the IntelliSense will do it for me. That is so cool, so cool. Okay, so that'll get me there. That'll get me there, and then what I would like to do is have this guy take in, let's see, this guy needs an enumerable to start, items. So I want to make this guy work here. Let's see, adds async enumerable. That. So we're going to do that, and then this becomes items. Okay, so this should get, we're just going to wrap this up in a pretty bow. That's really all we're doing. So this should get me this, turns async enumerable. So oh, I misspelled it. That's the problem. Okay. So this gets me the first one. Now, the one thing I did also want to have as well is the ability not just to pass in a collection, which is what this themes is, but to pass in an individual one as well. So we can take this guy here, and rather than taking in an enumerable, what we can do is we can leverage a params array. So in C#, if your last parameter is prefixed with the keyword params and is an array, the compiler will take care of converting an individual list of items. So the compiler will take care of converting the individual list of items into an array for you. And in general, you can rely on the fact that this array will never be null. The only way for this array to be null is for somebody to be highly explicit about the way they invoke it. So they would end up having to do something like they couldn't even do null, right? If they pass null in, what they would end up getting is an array with one item and null inside of it. Like it really has to be a highly explicit, like themes array of null. What is this here? Let's just break it up here. Oh, not theme. Theme. There. So it really, like, that's the effort you have to go to in order to get a null into that array. So usually the recommended practice is don't bother checking this for null. If somebody does it, they deserve what they get. Okay, so what we're going to do here is we are going to suppress the warning because this warning isn't relevant to us. We're intentionally doing it like this. But now we have this lovely little guy that we can use. I think I mentioned it last time. I try to treat my unit tests as just as good, if not better, than the code that's being tested. So my strong opinion is you should spend time refactoring your tests, making them clean, adding extension methods to your tests to make it easy to work with, easy to write. So now the test should work on the next invocation. Come on. Come on. Live unit testing. Go. Just make sure it compiles. Does it actually compile? What are you squawking about now? Oh, fine. There we go. Took it a minute to catch up. I suspect some of the other tests that have like the cancellation token timeout are really slowing down the live unit test run. But that guy there is better. Okay, all that effort. Let's drag this back over here. I'm gonna just rerun these live unit tests, and then we will. We'll see if we can knock a couple of these out. So this one here was a simple one. So before, what we had is we had the process service that was doing it. And now all this method does is shell out to the theme manager. So this test here is, I would say, a low value one, but all we have to do is change it to be theme manager. And we'll go theme manager. And then what we want to do is verify that, theme manager mock. We want to verify that it doesn't call start, but that it calls open theme directory. And this actually simplifies the test significantly because we no longer care about the actual details of what that method does. This is the idea that I presented last week of when you're writing these tests with mocks, you can either call into your view model, which is kind of like testing from on top, or you can use the mocks as the dependencies and do assertions and sort of test the interaction of your view model and what it invokes, so going down. So that guy there now passes. Huzzah. Let's see. Refresh loads themes. We're going to come in here and double check what this guy is doing. So this timeout here is almost assuredly what's biting us and making things run slow. We're going to just dial that down for a minute. So the other thing that's important to note, and we can start to abuse threading a lot right here. So this is refresh command execute. So if we go back and look at our refresh command. So on refresh. And I think I made a comment before that we can test the command or we can test the execute method. So if you test its execute method, you have to make it public so you can reference it. Great. But the point of this, which is what we did on this test up here. Right, we tested the method directly. But down here, we're wanting to go through the commands. So we don't have a great way of waiting for it because of this task run right here. So what we ended up doing was the task completion source, watching the property changes, yada, yada, yada. But you'll note, just from these blue lines here, I can tell that I never actually got into here. We never hit a property change, which means we are hitting the exact same bug that we did before. We can debug just to confirm. Why is debug test not giving me an option? Hello? Oh, because you're still running. Stop running. On refresh command, so if I debug this guy, or our new test, the one that we were trying to write, is, we'll say not quality. Boom. So yeah, same no reference, same method invocation. Not surprising. So we can come in here, we can actually come right up here, and we can do pretty much the exact same 2 lines of code that we did before. We can bring these guys down here. It's not strictly necessary to do this before we call create instance, by the way, but it is important that we do this before we call the method under test. So because AutoMocker keeps a dictionary under the hood of all of the stuff that it's created, the only difference is whether it creates it before it calls your before it does your view model, or it creates it at the point where it invokes the view model's constructor. Okay, so that one now went green, which is good. So we should have these 3 tests if I run those by themselves. Uh-oh. Uh-oh. The Mountain Dew can is empty. Okay, let's get to where we got hung up on before. Okay, so this is where we got stuck at before. We want to test the receiver for the message, because there's the pub submodel that we have built up, and we want to actually make all of this work. So there's a few things I can tell right out the gate that we can clean up. So for starters, create theme is no longer a dependency of our view model. That was one of the things that went out of the constructor and got buried inside the theme manager. So step 1, get rid of that. Our setup is going to get a lot simpler really quick. We're still going to need the messenger, because the trigger for this is actually the message that it registers for. So specifically, the method that we're looking to test is this async void recipient. Now, the comment from earlier about abusing or I should say from last time, about abusing the await on a completed task is what we're going to use to get this thing tested. So normally it would be really hard to test an async void, because we would need to have some concept of when did that thing complete. And so I guess technically we have 2 ways of doing that, because now, before, these save theme calls were actually shelling into local private functions that were doing file IO and all kinds of stuff. And so there wasn't a very clean way to know when were those methods done. So the 2 ways we can test this are, because this is now a dependency and a seam in our code, we can control the task that gets returned from save theme. And so we can ensure that the task that we return is already completed, and thus will be a synchronous call for us. So we can force an async method to be synchronous just by being able to control all the tasks being completed. The other way we could do it is we could set up, similar to how we did it with the, was this one here, with the property changed, where we used an event to know when the method was done executing. Or at least knew that it was far enough along that we could do our assertions. We could act, because we know when save theme gets invoked, these theme managers here, in addition to these setup and return, another method that exists on the back of these is callback. So you can just have an arbitrary delegate that gets invoked whenever, in this case, get themes is invoked. And you can do whatever you want in that delegate. You can check parameters, do assertions, set up maybe a task completion source and complete it. Anything you need to in those callbacks. So by moving that code out of a private function and into a dependency, we've now made this view model very testable, because now I can do whatever I want on that dependency. I don't need to test the downstream file stuff anymore. I can just have this thing work, which is great. It's kind of what we want. So what was the condition under which we were testing? So if we name this brush updated message updates theme file. So in this case, the condition, so the brush updated will be the message being sent here, which I believe we set up, and then it updates the theme file. So in this case, what it was attempting to do is actually tweak a lot of this stuff here, and this is a whole lot of whack. We're just gonna get rid of this. Okay, we ain't doing any of this garbage. We aren't gonna do property change stuff anymore. We aren't gonna do waiters anymore. Okay, and we are going to not do that anymore, which means we don't need that, which means we don't need that. We're just gonna clean some stuff up. So, this was the key point from last time. So if people haven't watched it, allow me to summarize the entire video from last time. Think about what you're testing and ask what is important to test. There, I just saved you a bunch of the video. So the important part with this is when we are testing this, and this comes down to how we name the unit test. When we are testing, what we want to ensure is that it updates the theme file. That's what's important to test. Right? We capture what we're trying to test right in the name of our unit test, so that when Kevin comes back to it in a week and can't remember what he was doing, he can just look at the name and jog his memory a little bit. And if he couldn't remember the name, he was going to rename his unit test. So in this case, I'm going to change this from update theme file, since we've kind of abstracted away the concept of files, to just updates theme. So specifically, updates theme is going to be defined as calls theme manager save theme. That's what's going to be important to us. So let's go ahead and put in this guy here. But what we're going to do here instead, we're going to call save theme. Okay, and so we want to ensure that save theme actually gets invoked. And so let's do theme, current theme gets new. Do that real quick. And actually, let's actually bring this guy up. So we're going to do this. We're going to just put this guy up here. So what we want to ensure is that that is called, and I'm going to say that it's important that the selected theme is the first parameter that gets passed. So mock by default will check those parameters to make sure that they match. So we will set selected theme as the first parameter. And then for the theme categories, I don't know if it's overly critical what gets passed. I'm going to say it doesn't really matter. So it is any. So we will let this setup match any enumerable of theme category, I believe is the syntax of this guy. Yeah. Okay, so when save theme is called. Okay, so by default, mock on an asynchronous method, it will just return a completed task for us. So we could be very explicit and goes returns task, completed task if we wanted. Not strictly necessary. That will be the default for a task, because mock is hip and cool and awesome. Okay, I may have gotten a little over eager with some of this stuff, but theme color and previous value. So let's look at what these are. Previous value, theme color. So let's just create a theme color, I think. Var color gets new. Theme color. Test color. And this will be messenger. We will put this guy in. Let's see, and let's set a value on him of old. Previous value will be old. Let's see, right? That's where it is. Previous value will be old. This will be new. So we'll do that. We'll do that. Okay, so now the assertions that we need to make. These things don't matter. So the method that we're testing, we don't actually care about most of this stuff. We know that it's pushing something onto the undo stack, so maybe we will check and see that something was pushed onto the undo stack, because we are in the case where previous value is not going to be null. So perhaps we will validate the undo stack, but then more importantly, what we want to validate is this save theme. So we could do a verify call like what we did before. The other thing we can very easily do is we can go theme manager, verify all. And so what verify all will do is it will ensure that anything that we do a setup on is in fact invoked, which is pretty cool, because if I have multiple things that I want to check, I can ensure that save theme is there. Just for proof of concept, for example, if I comment this out, we'll see this thing fail because I have a setup on save theme and it's no longer being invoked. If I put it back, test runs, everyone's happy again. So that previous test that was a pain in the neck and was previously needing async is now a synchronous test. So simply by abusing the completed nature of a task to automatically run synchronously, we have a functioning test. So I see that you don't write at the end of async methods an async suffix. That seems to be the convention, or is that not important? Oh, Justin Bieber, you are on point for hitting all of the flame war topics tonight. I applaud that. Okay, so just like I did with the tabs and spaces, I will attempt to outline both sides' arguments and the pluses and minuses of each. So, people who advocate for so just to be clear, so for example, this method is called save theme. Some people would argue that because this is an asynchronous method, it should be called save theme async. And then some people omit it. And I believe you are correct. The people who advocate for including the async suffix on the end of methods that are async, I think are probably the majority. I think. I haven't exactly taken a poll, but just based on personal experience, I think they probably do exist in the majority. So the arguments for the async suffix are it makes it much clearer when code reviewing, because quite often when looking at code, the only way that you would know that this is an async method is by the presence of an await. But hypothetically, if somebody forgot to await it, outside of the compiler yelling at you to await it, which, for example, it might not, right? So inside of here, so the only reason I had a warning is because I had async here. But if I'm just in a synchronous method and I don't include it, there's nothing in the IDE telling me that I should await this method, outside of me looking closely at it. So usually the people who advocate for always putting the async suffix on the method, this is their prime example that they'll go to of, hey, when I'm reading the code, I've got no indication that that's an async method without doing something else, popping IntelliSense, looking at the method on the hover or similar. If I'm just reading the code straight, like out on GitHub or something, I've got no indication that that is an asynchronous method. That's usually the argument for doing so. The argument against putting it on there, believe it or not, sometimes the argument is made for laziness. And then the other point that often gets brought up is if there are no synchronous overloads and an entire library is async, what does it matter? Now, obviously, that is not true in this case. Because, for example, I've got, 5 asynchronous methods and 1 synchronous. So sometimes the argument is made, well, if everything's asynchronous, then it's sort of well known and it's not needed. And you will see that stance taken in some libraries where they've done full asynchronous everywhere and haven't put the async suffix on the end. So yeah, I think those are the two places that go back and forth for it. So Okay, so that's kind of the two positions, and I hope I've captured them fairly. Personal opinion. I find typing honestly, a lot of it comes down to laziness, and I find typing the async suffix can be problematic. Now, with that said, if I am building a library, like a NuGet package that I intend to have consumed by other developers, I will probably move towards putting async suffix on the end of the name, because at that point, the audience of who's going to have to see and work with that API is much bigger. It's not just me. Something like this, where I'm likely the only developer, there might be, a handful of people that maybe chime in with pull requests at some point or whatever, probably not a big deal. I'm not overly concerned about it. So, and that largely comes down to laziness. Is it a better API? Probably not, especially since I probably wouldn't do it if I was trying to write a NuGet package that's consumed by other people. Yeah, there's been so let me pull this up. Let's see. Tech guidelines. So if you want a very long list, I think I shared just C#. I believe I shared this book that I was a technical editor on. So yes, I'm biased towards this one because I was a technical editor. You'll note this is C#8, not C#9, so just be aware of that. But the guidelines from that book are captured, and I'll just back up a little bit, are captured here, and I believe there is some async. Oh no, probably not. I think we may have ended up punting on that. So don't laugh at our website. We're working on redoing this with something much cooler. Announcements forthcoming in the next year. Doesn't have it on there. I thought we had an argument, not an argument, a discussion. We have lots of discussions on this, specifically around whether the async suffix was needed or not. Let's go async suffix. Maybe not. Maybe we, or I remember the. I remember we had a discussion on it. We may have not captured it here, which is disappointing because we've been trying to capture our discussions for or against different guidelines. So a lot of these guidelines currently lack the rationale that is covered in the book. But if you are looking for generalized coding guidelines, these are very, very good. And I would argue we have hashed on these a lot. There are, the only one that usually gets people, raises their hackles a little bit, is the one for properties. Oh no, it's not properties, it's fields. Fields is the one, because properties is what makes sense. Fields. Public static read only, blah blah blah. This one here. Do use Pascal casing and a leading underscore and an I prefix for interface names. That's kind of superfluous here. But the Pascal case and leading underscore. So what that would mean is a field, you would end up doing so like private int, foo is how a lot of people would do it. These ones would argue for foo. And the rationale behind it is because then your field and so there's another guidance that says fields, or I don't think it's quite as strong. I think it says consider fields should only be accessed by their containing properties. Now, that doesn't always work for things like ref and similar. So there are cases where it matters. My workaround, and what happens most of the time, you'll note I tend to not use fields and almost exclusively use auto properties instead, because auto properties get named with Pascal casing anyway. The compiler is going to generate the field for me. Oftentimes the compiler is going to inline the invocation straight to that field, so I'm not taking any performance hits by having a property instead of a field, and it reads easier. If I decide that I want to add a body to this later, I can do it without much overhead or change. Bippity boppity booyah, done. So, but yeah, I think that naming on field, where to go? That's the one that usually gets, most of these things are most of these guidelines are Visual Studio default. So if you just blind install Visual Studio next finish, I think like 80% of these just kind of align with the defaults, but they're formalized here. Doesn't provide a settings file with preset formatting rules. Not exactly. What we do have, and it's not clear from here, there is an editor config in the repo. So a lot of the guidelines are Visual Studio defaults. Some of the guidelines are captured via the editor config, which if you are interested in them, you can just drop this editor config into the root of your repo. The other one, some of them we have written analyzers for. So my comment earlier about those analyzers and code fixes, we wrote, so most of the analyzers don't have code fixes, they just find problems. Where did the link go? So there are, so specifically like that naming one, there is an analyzer one that is built in there that will flag it. There's ones for property naming to ensure Pascal case of property, which is the default that IntelliCode is going to do for you anyway. So this one's not nearly doesn't nearly flag as many things. Methods being named with Pascal case. This tends to be the default for a lot of people, but occasionally I'll see people use lowercase names. It's worth noting that the naming that we have for functions, we oftentimes will disable some of these warnings for unit test methods, because the unit test methods, like you'll note the way I write them here, they're kind of Pascal case, but they're intentionally broken up with underscores. So oftentimes that particular method naming rule will disable in our unit test project. But so there's the main coding guidelines page has a link to the I won't say a lot of analyzers, but we have several of them here. And we tried to break them into relatively good things. So naming, formatting, reliability, and performance. Naming and formatting, hopefully it's clear, those are more stylistic than functional. So sometimes people are like, well, when should I turn it off? And if it's stylistic, it's a whole lot easier to justify turning it off. This one here is intentionally flagging async void methods. This one, I usually turn this rule off in WPF projects in a lot of cases, because the async void is meant for top level event handlers, which is pretty much your desktop apps or thick client apps that are going to have those. I oftentimes will get rid of this. If you're in an ASP.NET Core application, I don't know if there's a single reason you should ever have an async void. So there is some thinking that has to go in for which ones you turn on and off. And we did try to put in on a lot of these when it is okay to suppress it, because it is worth noting when those ones do. And we've got a formatting bug here. Excellent, because that's date time to date time offset. That was another one in here. Let's see what's performance got in here. Oh, this one's actually worth calling out a little bit too. So I actually ran a performance benchmark the other day on these two particular methods. And it's worth noting, at least on .NET 6, where I ran the benchmark, if you fully enumerate all of the files in a directory, the performance between these two methods is pretty much negligible. It was within the margin of error. So if you're fully iterating, it doesn't really make a difference which one it does. However, for every other situation, you probably want to use enumerate files over get files. And since the performance of them is equal in the worst case scenario where you iterate all of them, the suggestion is to always just use the enumerate ones. The similar thing can be said for enumerate directories. Same type of thing. And the key difference is the get methods return an array, the enumerate ones return an enumerable. So the difference being that move next that we were looking at before, where it can just get the next one, rather than having to look through your entire file system and pull them all out, it can just grab one at a time. Which, especially if you're just saying, hey, I want to find the first folder that has, an X in the name, this is likely to exit early and not have to go through all of them, whereas this one is guaranteed to go through all of them. So this one, probably not what you want. So, and then local variable unused. If you declare a variable, use it. So yeah, we have some of them in there. If you do use them and find bugs, let us know. We've got those analyzers running on several large projects, so I will be surprised if there's too many bugs with them, but because analyzers rely on looking at the code itself, people's style choices can oftentimes reveal bugs in an analyzer. So if you do run across any or have questions, you can feel free to open an issue on the repo. Like I said, there's going to be some big changes over the next year for the coding guidelines and the access to the information and book content and all of that. So stay tuned. Sometime in the next year, there will be a cool announcement coming. Okay. Sweet. An interesting question. What do you think if you made something, a product of film, and gave it to the society, and a large number of people began to use it, and your product no longer belonged to you but belonged to the society? I mean, in a lot of ways, that kind of follows a lot of the open source mentality. Because, so just quickly drawing some parallels to like open source projects on GitHub or similar. It's not a perfect one because on GitHub there's still like owners of the repositories and whatnot, so it doesn't necessarily belong to all the consumers, but all the consumers are free to use it and fork it, and if they don't like something, fork and do what you like. I think it honestly comes down to the expectations of how things were set up, and I think that's why I like a lot of the. I get very hesitant to use any library that doesn't have an explicit license on it. So I like how GitHub prompts people to put licenses on their repositories for that reason, because it makes it really clear under what conditions I'm allowed to use a library and which ones I'm not. And I think in this situation, it would like in the film or similar, it would come down to that same type of thing of what was it licensed? Like if it was put out and what is it? Is it LibriVox? I think it's LibriVox. Yeah, this one. So random, not related to anything. But if people are interested in audiobooks, so this is, as the large tag name describes, LibriVox is audiobooks read by volunteers and put out online free for everybody to consume. So it, in some ways, it is similar to the film or media, but in this case, it's put out with the explicit license of all the recordings that are done on LibriVox are explicitly licensed in public domain, which is good. It tells whenever you play one of these things back, the very first thing that you hear right out the gate is that all LibriVox recordings are in the public domain. Perfect. That it's clear on what the license was. So I think it really depends on the license, which comes back to expectations of when things are allowed to be used and in what context. So I honestly don't have any problem with it. If it was a product that I built that I was trying to sell and it was intentionally licensed that way, I'd probably be a little more miffed. Like, that would bother me. But if it's something that I built, like I have quite a few NuGet packages I've published, and most of them are licensed MIT, which pretty much gives people license to have at it. Means I may not back if there's flaws or whatnot, but I'm not restricting how people consume the product, and have fun with it. Great. That's good. That's the way it should be. So I think, yeah, it would come back to the expectations and how it was licensed, of whether it would actually bother me. Because in most cases, I think I like the open source mentality of share and share alike. Which is why most of the stuff that I build oftentimes ends up open source. Building something to try to make a profit on it requires effort, and oftentimes I just don't want to go to that effort. Unless I thought I had like $1 million idea, then I might go to the effort. But so far I haven't had any idea where I feel like it's going to be worth $1 million. If I do, it won't be licensed MIT. I'll actually sell it. So, cool. Great questions, Justin Bieber. I appreciate it. Okay, I'm going to get this code checked in before I get too carried away. Let's see. Unit tests are now working. Commit change, push, and then let's go. Yeah, start a pull request to origin from origin unit test. Yes, that is what I would like. And I would like to go into master, adding unit tests. Lots of refactoring and a unit test. Something, create pull request. Boom, jump there. I can't remember. Oh, good, I do have a build set up. So as long as this build passes, which I don't think I left any of the tests in a failing state. Maybe I should have checked that before I just blindly submitted the PR. Should have probably run the test locally. That's good practice. Run tests locally before blindly submitting a PR. Otherwise, then you look dumb. Oh, good. They all pass. Okay. I thought I left them in a green state. You'll note before we had tests that were running for seconds, like 5 or 6 seconds. Less than half a second. That's what unit tests should be. Fast. Very, very fast. And the ones that are slow are going to be the ones that tend to rely on these event callbacks and similar to do it. The other ones that are just straight method invocations, bang, 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 bang. As long as that build succeeds, which I see no reason why it shouldn't. I think I may call it for the night and get going. There is a chance I may end up streaming a little this weekend. I might end up with some spare time. I'm waiting to figure out. I was potentially going to end up having to do some work stuff, but that may go away. Oh, boo. My build failed. What'd I break? Get assembly version task. NuGet version. Huh? Oh, my p.dot version is empty. Well, that's probably not right. What'd I do? So p version, environment build version. I mean, we set this thing up to work. Base version. Am I stupid? Oh, set version is disabled. It only runs when not pull request. That's incorrect. I actually need it always, so we're gonna just turn it on. I realize it's doing work that it probably doesn't need to do, but it's so small, whatever. Let's see, what was this? Oh, discard those changes. Page file. Fixing PR version. Push. Let's see. And question about completed task. What should I look at? Completed task successfully completed. To look at the status of the task. Okay. So let's jump back over to our task test. So the idea being around if you've got a task instance. So task gets task.run. So I believe if we look at this, so the question being is on a task there is a status enum that you can get at here. And the enum has 5 members? No, more. Yes, a bunch of stuff. The typical things people will work for. See, these ones are often all about when you instantiate it and when it gets queued into the background worker. Running tasks have a concept of a hierarchy, which is what the children are. But typically what people are checking it for is one of these 3, because a task, once a task is done, it's going to be in one of these 3 states. It either ran to completion, it was canceled, or it had an error. Those are really the only choices. And I believe if we look at, I believe is completed is just shorthand. Yeah, so the docs here show it, but I think we could probably check it on source.net too. So is completed is not quite the same as ran to completion. So is completed basically says, is it in one of the done states? So it'll specifically call out ran to completion, faulted, or canceled. So those bottom 3 enum states that it got into. So is it done running is really another way to say it. So is completed will guarantee that the task is done running. Doesn't mean that you know how it finished running, whether it finished because it was done, whether it had an error, or whether it was canceled. You might be looking for is completed successfully, which is going to basically be the equivalent of checking the status for ran to completion. So this might be what you're looking for. And oftentimes if you're checking the status, it's often because people are then going to want to know if they can go and pull the result off of it. But there's also is faulted, which is just telling you if your state went into the faulted and is canceled. So these properties here, is canceled, is completed, is faulted. All 4 of these properties are really just helpers around checking those bottom 3 statuses of the enum. So either one will be fine. You'll end up with the same result. So if you want to know if it's done, this one is probably the most valuable because it'll check against all 3 states. But if you only care about did it finish successfully, because if it was canceled or faulted, you're not guaranteed to actually have gotten a result because it didn't run to completion, or it didn't run successfully to completion. So that is worth noting. And I thought there was a correct, yeah, is completed. This is a guarantee that the task is completed, but it could have completed successfully or with an error. Yes, that is exactly correct. So is completed just tells you it's done. It's up to you to check if you care about one of those other statuses. Sometimes all you care about is, was it done? And I believe, don't quote me on this, if you call like .result on the end of it, I believe that throws if it completed with by cancellation or with a fault. I'm pretty sure .result throws in those cases. I could be wrong though. In this case, I'm looking at the non-generic task, so I don't have a dot result because this is the void equivalent. Let me look at just jump over to this guy. Yeah. So if there was an exception, this is guaranteed to throw. I don't know what this does if it was canceled. I have to, oh, task canceled exception. So yeah, this is going to throw if the task was canceled, or if the task had a, or if it was faulted. So in either of those cases, you will end up in that situation. So yeah, I assume this is for the task that you were going to feed into like a when all. You want to go through and iterate on them afterwards to check their status and pull information out. Yeah, I am a little tired. I got to be up early in the morning. So I kind of want this PR to finish. Oh, and I'm not even looking at it. Oh. Back to the PR. Oh, what? What? Oh, see? GitHub, you lied to me. Cool. Okay, so squash and merge, because we're going into the main branch. I like linear history, and I don't like my history. So squash is the appropriate option there. Boom. So all of the code from last week and tonight now out on the repo. Default branch. It's all there. So, and I left in all of those extra tests that we did too around like enumerable and threading and whatnot. So I'll probably leave them there. I don't know if I'll clean them up. Sometimes I clean them up just because they're adding context. They look out of place for the repo but they make sense for people watching the video. So, probably leave them there. Probably leave them there. This app has been a good teaching application. So, but I think with that, I am going to sign off for the night. Thank you everyone for coming and hanging out. For everybody who followed tonight, I appreciate the extra follows. Feel free, always, I love getting comments on the videos, especially if people have suggestions about what they want to see. I know there was a comment on one of the YouTube videos earlier today about wanting to see something with authentication for WPF. So I don't know if I'll get to it next time, but that's actually, I've got another project that I use as a teaching application that I've been wanting to add it to, so that will probably be coming up in one of the future weeks. I don't know which one. So, but with that said, I'm gonna sign off. Thank you everyone. Happy coding. See everyone next time.